everybody, fellow statisticians. I'm going to walk you through 13.2b a little differently. I went ahead and wrote everything out. That way I can just kind of point to it, highlight it as we go. Maybe take less time on the video. So let's see if you can follow along with me. I'm doing the state plan due conclude, and each one has a different screen with it, so a little bit bigger too and easier to read. First thing you got to do is you have to identify your two population parameters. You always have to do this. You have to tell the reader what P1 stands for and what P2 stands for. So I'm letting P1 represent percent of criminal records of Danish men with normal chromosomes. So they're kind of doing a study of seeing if chromosome abnormalities and being a criminal are related in some form or fashion. And so P1 are those Danish males that had a criminal record that were considered with normal chromosomes, and then P2 was the percent of criminal records of Danish males with abnormal chromosomes. So I'm going to set up my null hypothesis, which is always the two proportions are equal to each other. And then the alternative comes from the very last line in the prompt. It says, some experts believe chromosome abnormalities are associated with increased criminality. So because P2 was the one with the abnormal chromosomes, that's what I'm letting that parameter equal. I'm going to tell my alternative hypothesis to be P1 less than P2, because it says that chromosome abnormalities they want to investigate are associated with increased criminality. So I'm going to see if this is higher. My procedure, I still have to identify it, is called a true proportion z-test. And while I have the screen, I'm kind of going to go ahead and calculate what we call p-hat combine. So remember how that worked. This number here, 381, was the total number of men who had a criminal record with normal chromosomes, and then 8 was the total of men that they sampled with who had a criminal record with abnormal chromosomes. And then these are the two sample sizes. This is normal chromosomes, and this number here was abnormal chromosomes. So I have to figure out the sums of those. So 389 over 4,124 gave me, it's off the screen, but 0.094 was p-hat combined. So that's all part of my state information. Second part is the planning. So kind of walk you through each part a bit. Again, the 4 conditions never changed. We've always said they're the same, but the way we go about proving them kind of changed a little bit. Simple random sample. Well, as I read the prompt, it doesn't say. So I'm going to let the reader know that I didn't catch it. It's proceed with caution. So I know that it has a red flag. Second thing is addressing the population being at least 10 times sample size. Well, I just have to note that it's 2 different samples, so I have to do the 10 times n for both samples. So I'm assuming that 4,960 Danish men with normal chromosomes are in existence, and then at least 280 Danish men with abnormal chromosomes are assumed to be in existence. We're assuming independence, meaning each man chosen is not going to be influencing the next man that's being chosen, and then a normality check. And so remember how we incorporate p-hat combined. So I'm down here in this little section here, and I wrote the formulas out that you need to pay attention to. So sample size, first sample, N1 times p-hat combined, greater than or equal to 5 this time. Remember, we took one prop z-test. It was always greater than or equal to 10. So just think I have 2 samples. I'm going to split them in half. So N1 times p-hat combined greater or equal to 5. N1 times 1 minus p-hat, or p-hat combined greater or equal to 5. When I checked my numbers, I went ahead and calculated them out, and the first one was 385. The second one was 3,710. Both of those are okay. But when I worked with the second sample, N2 times p hat combined, and then N2 times 1 minus p hat combined, notice what happened when I did 28 times 0.094. He actually came out to be 2.6. Well, he's not greater or equal to 5, so I have to flag that. So I kind of did it in my yellow highlighter, and I'm letting the reader know, whoa, I didn't reach that condition in this particular sample. And so I'm going to just say proceed with caution. And so, I gotta say something about it. So that's why I'm talking about this. So proceed with caution is what you need to let the reader know. And then just go ahead and continue. Don't stop the test. Go ahead and continue. All right. The next part is the do. And so I'm over here identifying both p hat 1 and p hat 2. And so remember, p hat 1 was men with normal chromosomes that had criminal records. So 381 out of 4,096 gave me a percent of 0.093. And then p hat 2, 8 out of 28, 0.286. And so I'm over here doing the z-score. So remember the formula that I gave you. And remember this piece right here. This section, the denominator section, that is in or on your formula sheet. And if you got my remind yesterday evening or whenever, I kind of notated that on the formula sheet. So this doesn't have to be memorized, but just know that I'm using p hat combined and part of the denominator. Okay, and so I'm filling in my numbers in the next step. The reader has to see the numbers. Okay, and so I just filled it in. And I ended up getting a z-score of negative 3.48. Now again, you can do this in the calculator. It's just going to ask for certain pieces like x1, n1, x2, n2. All right, and when you fill that in, then you can run your test, and you're going to arrive at the same z-score that I have. So I drew a stinking sketch over here. And along with it, I copied down the p-value. Well, I hope you recognize after doing a few of these now that the p-value is pretty good. I'm going to compare it to 0.05 because they didn't give me a alpha level to use. So I'm going to default to 0.05. And so I'm just going to kind of show with it like an inequality. P-value is less than 0.05, so I get to reject the null. So my conclusion is I have enough evidence to reject the null and state that more criminal records are higher in Danish men with abnormal chromosomes. Okay, so something, in effect of mentioning this statement here as my alternative. That's an A there, okay? All right, so there was the part 1. So that's for the 4 parts state plan do conclude for running a test. And then the second part of the question just says perform or construct and interpret a confidence interval. So that's the next section here. So just like what you've been used to seeing, we're going to do our stating. Sorry, it kind of went off the top there. So it says constructed a 95% confidence interval for the difference. I don't think you can see that word there. It says difference in criminal records, percent difference in criminal records between Danish men with normal and abnormal chromosomes. I need to mention the word difference, and I hate that that kind of went off the screen a little bit, but that's what that word right there says. So the percent difference. And the procedure we're using is a 2 proportion Z interval. And in the planning stage, I'm still adjusting with my conditions. So I made a statement, all conditions were met in the previous problem because I ran a test first. But I do have to always check normality. And remember how the formula changes now. I'm not going to use p hat combined with a confidence interval. I'm going to use each of the sample sizes and each parameter. So n1 times p hat 1. N1 times 1 minus p hat 1. Both of them have to be greater or equal to 5. So in this section here, I checked that condition. So 381 was greater than or equal to 5, 3,715 was greater than or equal to 5. So I'm good to go with the first sample. And then in the second sample, N2, sample size, sample 2 times p hat 2 greater or equal to 5, N2 1 minus p hat 2 greater or equal to 5. So on both of these, when I actually did the math, I came up with 8 and then 20. So in the confidence interval, I did achieve normality, so I'm safe to proceed. And going to the do part, remember our formula here. We're doing the difference between those two samples. And so P1 minus P2, P hat 1, minus P hat 2, plus or minus the Z critical value, again from your table. But then again, I notated this on your formula sheet yesterday. And so notice the difference. I'm not using p hat combined. I'm using the sample proportions that we had from previously. So these numbers here are the ones that are going to belong under the radical that's considered my standard error. So I'm filling in my actual values. And so notice the same numbers. There's the 0.093 and then 0.286, 0.286, 1 minus 0.286. And I come up with this interval. And I'll let the calculator do this for me. And if you notice when you go to the calculator, once you ran the test and you chose the 2 proportion Z interval, your numbers were still in there. All you had to do was adjust the confidence level that you're using. And so here's what I end up with. And some conclusions. So I wrote 2 different conclusions here just to kind of get you used to seeing how to word it. And there's several different ways to word it. So one way to word it, notice that the negative, the confidence interval that was created, they're negative numbers. Well, the reason they're negative is because, remember, when I looked at the difference, this was normal and this was abnormal. Abnormal was way higher in percent, so when I take the difference, he's going to dominate my sign. So that's why I ended up being negative. And so that means abnormal is higher. And so when I word the answer to the question or the context, I'm going to kind of lean it more toward abnormal chromosomes. So we are 95% confident that the true proportion of Danish men with criminal records is between 2.5% to 36% higher for those having abnormal chromosomes. So I just dropped the negative sign and I just worded the context in favor of the abnormal because he dominates my negative. He's dominating because that's why I have a negative sign. Another way to say it is we are 95% confident that the true percent, and you can say the word difference, of criminal records between Danish men with normal chromosomes and those with abnormal chromosomes will be between 2.5% and 36%. So in this particular situation, I just dropped the negative altogether and I used the keyword difference. I didn't lean it more toward or favor it more toward one type than another type. I just said the word difference will fall between 2.5% and 36%. So if you get hung up in trying to explain the confidence interval and context, this is probably your better statement if you don't really get how to explain the first one. So you can always use the word difference, and you know, you're probably not going to get counted wrong even if you did put negative signs there, okay? Because they're going to see how you arrived at that answer because you're going to provide a formula. And so they'll understand why your negative signs are there if you do include them. So I hope I've done a better job of maybe explaining it, maybe not taking near as long, but just try it. So hopefully you can work two of them for me, 13.2C, and then we're skipping 13.2D. Don't do that one. But then number 9. So 13.2C, and then the next one is number 9. So see what you can do with that for Monday, and I will give you some feedback. I'll show you some answers, and then I might just, leave you to do A and B on your own, and I'm not going to make you submit like I did the last time. I'm just going to let you try them and check your work, because I just want you to understand it, okay? And then we'll see where we go from there on Monday, okay? Hope you have a great weekend. Thanks for putting up with me. Bye-bye.